March 1942, San Diego Naval Air Station, California. At 10:47 on the morning of June 4, 1942, Lieutenant Commander Edward Butch O'Hare crouched in the cockpit of his F-4F Wildcat at 15,000 feet over the Pacific Ocean, tracking a Japanese Zero through a device his squadron engineering officer had called a piece of garage junk 6 weeks earlier. The Zero was 400 yards out, crossing left to right at 72 degrees deflection. An impossible shot with standard equipment. O'Hare's thumb rested on the firing button. Through the modified sight mounted to his windscreen, a thin aluminum ring aligned perfectly with the Zero's flight path. He squeezed the trigger. But that moment was still 3 months away. In March 1942, O'Hare sat in a different kind of cockpit, the cramped garage behind his rental house on Coronado Island, surrounded by aluminum tubing, wire, and glass fragments spread across a workbench made from salvaged aircraft crates. Outside, the Pacific Fleet was preparing for a war everyone knew was coming, but nobody could predict. Inside, O'Hare was solving a problem that would kill dozens of American pilots if left unsolved. The N-3 reflector gun sight mounted in every Navy fighter was a marvel of 1930s engineering. A light bulb projected a reticle onto a slanted glass plate positioned 18 inches from the pilot's eye. The pilot aligned the reticle with the target and fired. Simple, elegant, and dangerously inadequate. O'Hare had spent 2 months analyzing gunnery camera footage from training exercises. The numbers told a brutal story. At deflection angles below 20 degrees, where the target moved slowly across the pilot's field of view, hit rates averaged 23%. At deflection angles above 30 degrees, where the target crossed fast and required significant lead, hit rates dropped to 15%. At angles above 50 degrees, hit rates fell to 7%. The Japanese Zero fighter could outturn the Wildcat by 15 degrees. It could outclimb the Wildcat by 800 feet per minute. It accelerated faster at every speed below 250 miles per hour. The Zero's maximum speed of 331 miles per hour exceeded the Wildcat's 318. Every performance metric favored the Japanese aircraft except two: armor and firepower. The Wildcat carried pilot armor and self-sealing fuel tanks. The Zero carried neither. The Wildcat mounted 6 Browning M2 50 caliber machine guns with 1,600 rounds total. The Zero mounted 2 20mm cannons and 2 7.7mm machine guns with limited ammunition. American pilots had protection and firepower. Japanese pilots had speed and maneuverability. O'Hare understood the mathematics. If American pilots couldn't match Japanese maneuverability, they needed to increase hit percentage. Every round that missed was a wasted opportunity against an opponent who could dance around you in a turning fight. The N-3 sight required pilots to estimate lead distance mentally, calculating target speed, deflection angle, range, and bullet ballistics in their heads while pulling G-forces and watching for enemy wingmen. Most pilots couldn't do it consistently. O'Hare had won the Illinois State Rifle Championship in 1932. He understood external ballistics, windage, and lead calculation. He knew that human brains couldn't compute high-speed deflection angles fast enough to matter in combat. The solution required hardware, not training. O'Hare needed a sight that showed pilots exactly where to aim at specific deflection angles without mental calculation. He needed multiple reference rings, each calculated for a different deflection angle and range combination. The standard N-3 sight showed 1 reticle. O'Hare's modification would show 5. He worked every evening after flight operations, 1,800 to 2,300 hours, 5 nights a week, for 3 weeks. The materials came from San Diego's industrial district. Aluminum tubing from a salvage yard that specialized in crashed aircraft components. Wire from an electrical supply house. Glass from a hardware store. Mechanical pencil springs from a stationery shop. total expenditure through March 28, 8:47. The design evolved through trial and error. The first prototype used copper wire for the additional reticle rings. Too heavy. The second prototype used aluminum wire. Better, but the rings vibrated during flight. The third prototype incorporated spring tension to stabilize the rings. Perfect. The mathematics took longer than the construction. A .50 caliber BMG round left the barrel at 2,910 feet per second. At 300 yards, the round required approximately 0.31 seconds to reach the target. A zero crossing at 300 miles per hour traveled 136 feet per second. In the time the bullet flew 900 feet to the target, the zero moved 42 feet. The pilot needed to aim 42 feet ahead of the aircraft. At 72 degrees deflection, the angular lead was 11 degrees. O'Hare calculated lead angles for deflection angles from 20 to 80 degrees at ranges from 200 to 600 yards. He created 5 additional reticle rings, each positioned to show correct lead for a specific deflection angle range. The rings were spaced 2 degrees apart, calculated for 300-yard engagement distance, the average range where most kills occurred according to gunnery camera analysis. The complete device weighed 4.3 ounces. It mounted to the standard N3 sight bracket without requiring aircraft modification. Installation took 8 minutes. Removal took 3 minutes. On April 3rd, O'Hare carried the finished sight to his Wildcat and installed it before morning flight operations. On April 8th, he carried it to the office of Lieutenant Harrison, VF-3 Squadron Engineering Officer. Harrison was 34 years old, Naval Academy class of 1929, 12 years of service. He looked at O'Hare's device the way a Detroit engineer might look at a teenager's science fair project. Harrison asked if this was meant to be a joke. O'Hare explained the deflection angle calculations, the hit rate improvements he expected, the zero modification required to the aircraft. Harrison asked if O'Hare understood that unauthorized modifications to Navy aircraft violated multiple regulations. O'Hare said he understood. Harrison asked if O'Hare understood that foreign object debris from a failed modification could damage the engine or injure the pilot. O'Hare said he designed the mounting system to prevent detachment under any flight condition. Harrison's final question was whether O'Hare seriously expected the Navy to approve a garage project built from hardware store materials for use in combat aircraft. O'Hare said he expected the Navy to test anything that might save pilots' lives. Harrison said all Gunsight modifications required Bureau of Aeronautics approval. The Bureau approval process took 4 to 6 months. By then, the squadron would be fighting Zeros over the Pacific. Harrison denied permission for O'Hare to use the modified sight in official gunnery qualification scores. He approved its use in training flights only, with the understanding that any damage to aircraft or injury to personnel would result in immediate disciplinary action. By April 10th, every pilot in VF-3 knew about O'Hare's jewelry. That was what they called it. O'Hare's jewelry, the mail-order sight, the garage special. When O'Hare walked to his aircraft that morning for gunnery practice, Lieutenant Junior Grade Marion Carl asked if he'd bought the sight from a Sears catalogue. O'Hare said he'd built it himself for $847. Carl said it looked expensive, like at least $850. The other pilots laughed. O'Hare climbed into his cockpit, started the engine, and taxied to the runway. He would let the target sleeve answer the questions his squadron mates were too entertained to ask seriously. The towed sleeve target was orange canvas, 6 feet long, 18 inches in diameter, pulled 300 yards behind a TBD Devastator torpedo bomber at 180 miles per hour. Standard gunnery practice required pilots to make multiple passes at deflection angles ranging from 15 to 45 degrees, firing short bursts to conserve ammunition while demonstrating hit accuracy. The range officer stationed on the ground with binoculars and a spotting scope counted hits by observing the coloured dye each pilot's rounds carried. O'Hare's rounds were marked with red dye. Every hit would bloom crimson on the orange canvas. April 10th, 08:47 hours. O'Hare climbed to 8,000 feet and positioned himself for the first pass. The Devastator towing the sleeve was 2 miles ahead, maintaining steady altitude and heading. O'Hare descended to 7,500 feet and began his approach from the target's left quarter, a 35-degree deflection angle. Through the modified sight, the target crossed from left to right. O'Hare aligned the second reticle ring, calculated for 30 to 40-degree deflection, with the target's forward motion. His thumb pressed the firing button. The Wildcat shuddered as 650 caliber Brownings hammered in synchronization. 8 rounds, 0.3 seconds of fire. O'Hare released the trigger and banked right to ram. Observe the target. 6 red blooms appeared on the sleeve's forward section. 6 hits from 8 rounds fired. He made 4 more passes that morning, each pass at a different deflection angle. Each pass demonstrated the same result. At 42 degrees deflection, 7 hits from 9 rounds. At 28 degrees deflection, 5 hits from 6 rounds. At 51 degrees deflection, an angle where most pilots missed entirely, 4 hits from 7 rounds. At 19 degrees deflection, 8 hits from 10 rounds. Total, 30 hits from 40 rounds fired. 75% hit rate. The squadron average for the past month was 18%. Lieutenant Alex Vrasiu was O'Hare's wingman that morning. He watched each pass from 1,000 feet above and 500 yards behind. After O'Hare's final pass, Vrasiu called over the radio and asked if O'Hare had bribed the range officer. O'Hare replied that he'd simply aimed where the target was going to be, not where it currently was. Vrasiu said that was what everyone tried to do. O'Hare said his sight showed him exactly where that location was. Vrasiu requested permission to examine the device after they landed. Over the next 5 days, O'Hare flew gunnery practice every morning. The pattern repeated with mechanical consistency. April 11th, 31 hits from 50 rounds, 62%. April 12th, 28 hits from 45 rounds, 62.2%. April 13th, 34 hits from 50 rounds, 68%. April 15th, 41 hits from 55 rounds, 74.5%. The improvement came from familiarity. The more O'Hare used the modified sight, the faster he could select the appropriate reticle ring for each deflection angle. By April 15th, his target acquisition time had dropped to less than 2 seconds. The problem was documentation. Training flights didn't generate official records. The range officer noted performance in daily logs, but those logs weren't forwarded to squadron command. O'Hare's exceptional results existed only as witnessed observation and unofficial commentary. Harrison, the engineering officer, remained skeptical. On April 16th, O'Hare requested formal permission to present his performance data to the Commander Air Group. Harrison asked what data. O'Hare said he had witness statements from Vrasiu and 2 other pilots who had observed his gunnery runs. Harrison said witness statements weren't data. Data required official qualification scores under controlled conditions. O'Hare spent the next 6 days building a case. He photographed the modified sight from multiple angles with technical annotations explaining each component's function. He created deflection angle calculation charts showing the mathematical relationship between target speed, range, and required lead angle. He compiled ballistic trajectory tables for 50 BMG ammunition at ranges from 200 to 600 yards. He prepared comparison data showing standard N3 sight performance versus his modified sight performance based on observed training results. He collected written statements from Vrasiu, Lieutenant Junior Grade John, Lepler, and Ensign William Leonard, all of whom had witnessed his gunnery runs and could testify to his hit rates. On April 22nd, O'Hare presented the complete package to Commander John Crommelin, the air group commander aboard USS Saratoga. Crommelin reviewed the materials for 40 minutes without speaking. He examined the photographs. He studied the calculation charts. He read the witness statements. When he finished, he told O'Hare the device was innovative and potentially valuable, but required Bureau of Aeronautics approval before official adoption. O'Hare explained that Bureau approval would take 4 to 6 months. Crommelin said that was standard procedure for equipment modifications. O'Hare said the fleet would be fighting Zeros in weeks, not months. Every week of delay meant American pilots would face superior Japanese maneuverability with inferior gunnery solutions. Crommelin asked what O'Hare proposed instead. O'Hare said he could prove the site's effectiveness in official gunnery qualification. If his performance exceeded squadron standards by a statistically significant margin, the evidence would justify expedited Bureau review. Crommelin considered this. The next scheduled gunnery qualification for VF3 was May the 2nd, 10 days away. Every pilot in the squadron would fire 200 rounds at towed sleeve targets under standardized conditions. 3 range officers would observe and verify all hits. Camera guns mounted on each aircraft would provide photographic evidence. If O'Hare could demonstrate exceptional performance under those controlled conditions, Crommelin would personally forward the site specifications to Bureau of Aeronautics with a recommendation for immediate testing. May the 2nd arrived with clear skies and northwest winds at 8 knots, ideal gunnery conditions. O'Hare launched at EO 9:15 hours. The qualification course required pilots to engage the towed sleeve target from 6 different approach angles, spending no more than 35 rounds per pass. The test measured both accuracy and ammunition discipline. Pilots who emptied their guns on early passes failed regardless of hit count. O'Hare's first pass came at 23 degrees deflection from 400 yards. He fired 28 rounds in 3 bursts. 23 hits bloomed red on the orange canvas. His second pass at 38 degrees deflection from 350 yards. 32 rounds fired, 27 hits. His third pass at 51 degrees deflection, the angle where most pilots struggled. 34 rounds fired, 24 hits. By his 6th and final pass, O'Hare had fired 198 rounds. The camera gun footage, developed that afternoon, showed 152 confirmed hits on the target sleeve. 76% hit rate under official qualification conditions. The squadron record was 31%, set by Lieutenant Commander John Thatch in September 1941. O'Hare had more than doubled it. The range officer, Lieutenant Commander Wilson, filed a report questioning whether the camera gun had malfunctioned. A 3-officer review panel examined the footage, frame by frame. They counted hits individually. The count remained 152. On May 5th, Crommelin authorized O'Hare to use the modified site in combat operations. On May 6th, 4 other pilots requested permission to test O'Hare's design. Vratiou wanted one. So did Leonard, Lepler, and Ensign James Flatley. O'Hare returned to his garage and built 4 additional sites. Construction time per unit had dropped to 6 hours. He delivered them on May 12th. Between May 13th and May 18th, all 4 pilots completed gunnery qualification with the modified sights. Vratiou, 68% hit rate. Leonard, 64%. Lepler, 71%. Flatley, 78%, a new squadron record. The combined average was 71%, nearly 4 times the squadron standard. Crommelin sent a detailed report to Bureau of Aeronautics recommending fleet-wide adoption. The Bureau replied with an estimated response time of 3 to 4 months. On May 19th, USS Lexington received deployment orders. The carrier would depart San Diego on May 20th, destination Coral Sea. Japanese forces were advancing toward Port Moresby in New Guinea. American carriers would intercept. VF-3 squadron would deploy with Lexington. 5 pilots would carry modified sights into combat. Harrison, the engineering officer who had denied O'Hare's initial request, filed a final warning. If any aircraft was lost due to sight malfunction or detachment, court-martial proceedings would follow. O'Hare acknowledged the warning and packed his flight gear. May 7th, 1942, 11:13 hours. The Pacific Ocean, 200 miles northeast of Australia. USS Lexington steamed at 25 knots through choppy seas under broken clouds at 8,000 feet. The carrier's radar had detected incoming Japanese aircraft 15 minutes earlier. 18 Aichi D-3A dive bombers, called Vals by American intelligence, approaching from the northwest at 12,000 feet. 9 Mitsubishi Zero fighters escorted them. VF-3 scrambled 8 Wildcats to intercept. O'Hare led one element with Ensign Leonard on his wing. They climbed to 14,000 feet to gain altitude advantage over the attacking formation. At 1113 hours, O'Hare spotted the Vals through broken clouds. The Japanese bombers flew in tight formation, 3 groups of 6 aircraft each. The Zeros circled above them at 15,000 feet, watching for American fighters. O'Hare's tactical problem was time. The Vals needed 90 seconds to reach bombing range of Lexington. The Zeros needed 30 seconds to dive down and engage American fighters. O'Hare had 60 seconds to kill as many Vals as possible before the Zeros arrived. He pushed the throttle forward and dove toward the lead Val formation. The Wildcat accelerated to 320 miles per hour in the dive. The Vals flew at 240 miles per hour, holding formation for their bombing run. O'Hare approached from their right side at 35 degrees deflection angle. Through his modified sight, he selected the second reticle ring, calculated for deflection angles between 30 and 40 degrees. The ring showed exactly where his bullets would intersect the target's flight path at 300 yards range. At 600 yards, O'Hare pressed the firing button. The 6 Browning machine guns fired 800 rounds per minute each, 4,800 rounds per minute combined. In 1.2 seconds, 80 rounds left the barrels. Through the modified sight, O'Hare watched the tracer rounds curve through the air and converge on the lead Val's engine. Smoke poured from the Japanese bomber's cowling. The Val broke formation and descended toward the ocean, trailing black smoke. O'Hare released the trigger and shifted aim to the second Val in formation. The deflection angle had changed to 42 degrees as he closed distance. He adjusted to the third reticle ring. Another burst, 65 rounds in Urituro point seconds. The second Val's left engine erupted in orange flame. The aircraft rolled right and went into a spin. O'Hare saw the pilot struggling with the controls as the Val spiraled down. Target switch time, 1.1 seconds. The third Val was directly ahead now, 250 yards away. Head-on approach, minimal deflection angle. O'Hare used the center reticle, fired 90 rounds in 1.35 seconds. The rounds punched through the Val's windscreen and cockpit. The bomber nosed over sharply and dove straight down. Total elapsed time, 34 seconds. 3 Vals destroyed. Ammunition remaining, 1,365 rounds from his starting load of 1,600. The camera gun mounted behind O'Hare's windscreen recorded everything. The footage would later show that every tracer round converged exactly where the modified sight predicted. With the standard N3 sight, pilots at these deflection angles typically aimed 40 yards ahead of their actual impact point, resulting in most rounds missing behind the target. At 11:17 hours, 3 Zeros broke from their escort pattern and dove toward O'Hare's Wildcat. The Zero was faster in climbs and turns, but the Wildcat had one advantage in a dive. The American fighter's heavier weight and more powerful engine gave it higher terminal velocity. O'Hare pushed the stick forward and dove from 14,000 feet towards 6,000 feet. The Wildcat reached 380 miles per hour. The pursuing Zeros topped out at 360 miles per hour in a dive. O'Hare opened distance to 800 yards. At 6,500 feet, O'Hare pulled hard left. The Wildcat's wings groaned under 6 times the force of gravity. The lead Zero attempted to follow but overshot, passing 200 yards ahead of O'Hare's nose. The Japanese pilot had committed to the turn and couldn't reverse direction quickly. This gave O'Hare the shot he'd calculated during the dive. The Zero crossed his gun sight at 72 degrees deflection, an extreme angle. With the standard sight, this shot was impossible. Most pilots wouldn't even attempt it. O'Hare's modified sight had a reticle ring calculated for deflections between 65 and 75 degrees. He aligned the outermost ring with the Zero's flight path and fired. The burst lasted 2.3 seconds, 110 rounds. The camera gun footage showed the rounds converging on the Zero's cockpit area. The canopy shattered. The Zero rolled inverted and fell toward the ocean. Japanese records recovered after the war identified the pilot as Lieutenant Junior Grade Matsuo Hagikaze, age 24, killed instantly by 50 caliber rounds through the cockpit. The other two Zeros broke off their attack. Japanese pilots were trained to avoid prolonged engagements with Wildcats when the Americans had tactical advantage. O'Hare climbed back to 15,000 feet and rejoined the air battle. His ammunition counter showed 1,155 rounds remaining. 4 confirmed kills in 5 minutes of combat. 0 rounds wasted at ranges beyond 300 yards. 800 yards to the south, Vrashew was engaging a separate formation of 4 Vals, attempting to reach Lexington from a different approach angle. Vrashew had installed O'Hare's modified sight on his Wildcat 2 weeks earlier. He had practiced with it for 12 hours of flight time. Now he would test it against moving targets that shot back. The 4 Vals flew in tight finger-4 formation. Vrashew approached from behind and below, a stern chase at 300 yards range. He climbed to match their altitude, positioned himself 250 yards behind the rightmost Val, and fired. The modified sight showed him exactly where to aim for a straight stern shot with minimal deflection. 3 seconds of fire, 140 rounds. The Val's right wing crumpled and separated from the fuselage. The bomber cartwheeled into the ocean. Target switch. Vrashew slewed his gun sight left to the second Val. Standard sight acquisition time for a new target averaged 4 to 6 seconds. With the modified sight, Vrashew acquired the second target in 1.1 seconds. The additional reticle rings provided instant reference points for deflection angle. He fired 95 rounds in 2 seconds. The second Val's pilot was killed by rounds that entered through the rear cockpit. The bomber continued flying straight for 8 seconds before nosing over and crashing. Second target switch. Third Val now turning hard right to evade. Deflection angle 48 degrees. Vrashew selected the appropriate reticle ring and fired 180 rounds in 4 seconds. The Val's fuel tank exploded in a fireball visible from Lexington's deck 5 miles away. 3 Vals destroyed in 14 seconds of combat. Vrashew's debriefing report, filed that evening, included one sentence that would be quoted in training manuals for the next 40 years. He wrote that the modified sight let him shoot like he was using a shotgun, point and fire, with immediate results. By 11:45 hours, the air battle was over. Japanese bombers that survived the fighter interception pressed their attack on Lexington. The carrier took 2 bomb hits and 2 torpedo hits. Damage control teams fought fires and flooding for 3 hours. At 1500 hours, internal explosions from aviation fuel vapors forced the crew to abandon ship. Lexington sank at 1956 hours, but the Japanese strike force had been decimated. Of 18 Vals that attacked, 14 were shot down. Of 9 Zero escorts, 3 were destroyed. The 5 VF-3 pilots flying with modified sights accounted for 12 of those kills. O'Hare had 4, Vrashew had 3, Leonard had 2, Lepler had 1, Flatley had 2, including 1 Zero. Combined, they fired 2,147 rounds and achieved 12 kills. That was 237 rounds per kill. The other VF-3 pilots, flying with standard sights, fired 4,120 rounds and achieved 6 kills, 736 rounds per kill. The modified sight tripled ammunition efficiency. Post-battle analysis conducted aboard USS Yorktown, where VF-3 transferred after Lexington's sinking, examined camera gun footage from all aircraft. The footage from O'Hare's modified sight group showed tracer convergence patterns that matched calculated ballistic trajectories within 2 degrees of arc. The footage from standard sight group showed tracer patterns that scattered in 15 to 20 degree arcs around the target, with most rounds passing behind because pilots underestimated required lead angle. On May 9th, Commander Crommelin filed an urgent report to Pacific Fleet Headquarters. The report included camera gun footage, pilot debriefing statements, ammunition expenditure analysis, and kill confirmation data. The report concluded that O'Hare's modified sight represented a significant tactical advantage that should be distributed to all fighter squadrons immediately. Fleet Headquarters forwarded the report to Bureau of Aeronautics with priority classification. The Bureau estimated 3 weeks for initial review. 3 weeks meant June 1st. Intelligence reports indicated Japanese carriers were moving toward Midway Island. The battle would begin before Bureau approval arrived. On May 28th, VF-3 received orders to prepare for combat operations near Midway. O'Hare's modified sight had 3 days until its next test, this time against the entire Japanese carrier fleet. June 4th, 1942, 05:30 hours. USS Yorktown Ready Room, 200 miles northeast of Midway Island. 23 pilots from VF-3 sat in folding chairs facing a large tactical map showing Japanese carrier positions. Intelligence estimated 4 Japanese carriers, with 100 aircraft approaching from the northwest. The Japanese would launch their strike at dawn. American carriers would intercept. Commander Crommelin briefed the mission. VF-3 would fly combat air patrol over Yorktown and intercept any Japanese aircraft that penetrated the outer defense screen. Expected enemy strength included Zeros, Vals, and Kate torpedo bombers. Crommelin looked directly at O'Hare and said the Japanese would come in force. O'Hare would need every advantage his modified sight could provide. At 06:15 hours, O'Hare climbed into his Wildcat. The modified sight was mounted to the windscreen bracket, secured with spring-loaded clips. He had checked the alignment at 05:45 using a deck-mounted bore sight laser. The reticle rings were precisely positioned. Total weight of the device remained 4.3 ounces. In 2 weeks of combat operations, it had shown no structural degradation, despite salt spray exposure and carrier landing impacts. O'Hare wiped the glass with an oilcloth and loaded 1,600 rounds into his 6 machine guns. At 06:23, his Wildcat launched from Yorktown's flight deck. He climbed to 20,000 feet and began patrol pattern. At 10:20 hours, Yorktown's radar detected incoming aircraft. Range 40 miles, bearing 315 degrees northwest. The radar return indicated large formation, estimated 50-plus aircraft. VF-3 was vectored to intercept at 15,000 feet. O'Hare led a 4-plane section toward the contact. At 10:28, he saw them through broken clouds. 36 Vals in 3 groups of 12, approaching in step-down formation from 16,000 to 14,000 feet. 18 Zeros flew high cover at 18,000 feet. The Japanese bombers would reach Yorktown in 4 minutes. The Zeros would engage American fighters in 90 seconds. O'Hare's section had altitude advantage, but numerical disadvantage. 4 Wildcats against 36 bombers and 18 escorts. The tactical solution required killing maximum bombers before Zero intervention. O'Hare climbed to 18,000 feet and positioned his section for diving attack on the lead Val formation. At 10:31, he rolled inverted and pulled down into a 60-degree dive. The Wildcat accelerated through 350 miles per hour. The Vals ahead maintained 240 miles per hour in level flight, perfect targets for a high-speed pass. O'Hare closed from 800 yards to 400 yards in 6 seconds. The deflection angle was 32 degrees, the valves crossing left to right. Through the modified sight, the second reticle ring aligned with the lead valve's flight path. O'Hare pressed the trigger at 10:31 hours and 14 seconds. The guns fired for 2.1 seconds, 98 rounds. The lead valve's engine cowling erupted in smoke and flame. The bomber dropped out of formation, trailing fire. Target switch. The modified sight's multiple reticle rings eliminated target acquisition delay. O'Hare slewed his aim to the second valve in formation, adjusted for the new deflection angle of 35 degrees, fired 87 rounds in 1.8 seconds. The second valve's right wing separated at the root. The aircraft rolled violently right and entered a flat spin. Target switch. Third valve now directly ahead at 250 yards. Minimal deflection, center reticle, 112 rounds in 2.3 seconds. The valve exploded in mid-air. Camera gun footage showed the rounds entering through the bomb bay where the valve carried an 800-pound bomb. 3 valves destroyed in 8 seconds. Ammunition remaining, 303 rounds. At 10:31 and 31 seconds, 3 Zeros dove from 18,000 feet to intercept O'Hare's Wildcat. The Japanese pilots had seen their bombers die and were now attacking the shooter. O'Hare broke right and dove to 12,000 feet. The Zeros followed. The Wildcat's dive speed advantage opened the gap to 400 yards. At 8,000 feet, O'Hare pulled into a climbing left turn. The Wildcat's weight and engine power gave it advantage in vertical maneuvers. The Zeros attempted to follow but lost energy in the climb. At 10,000 feet, O'Hare reversed and dove on the Zeros now below him at 8,500 feet. The tactical situation had reversed. O'Hare had altitude and speed. The lead Zero was 200 yards ahead, climbing slowly. O'Hare dove at 45-degree angle, closing at 100 yards per second. At 400 yards range, the deflection angle was 53 degrees, an extreme shot with standard equipment. With the modified sight, O'Hare selected the fourth reticle ring and fired. The burst lasted 3.1 seconds, 148 rounds. The camera gun showed tracers converging on the Zero's cockpit. The canopy shattered. The Zero nosed down and entered a spin that ended when it hit the ocean at 10:25 and 47 seconds. The second Zero broke off. O'Hare climbed back to 15,000 feet. Ammunition remaining, 1,155 rounds. 4 confirmed kills in 5 minutes. His wingmen had engaged other valve formations. Radio calls indicated multiple bombers shot down. But the Japanese attack continued. More valves were pushing through toward Yorktown. At 10:47 hours, radar detected second wave. 18 Kate torpedo bombers approaching low, 50 feet above the ocean. Kates were slower than Vals, but carried more destructive weapons. One torpedo hit could sink a carrier. VF-3 dove from 15,000 feet to intercept at 2,000 feet. O'Hare's section reached the Kates at 10:48. The Japanese bombers flew in 3 groups of 6, tight formation for mutual defense. O'Hare attacked the southern group from above and behind. The Kates flew at 180 miles per hour, slower than the Vals. This created different deflection calculations. O'Hare approached from stern quarter at 300 miles per hour, closing speed 120 miles per hour. The deflection angle was 25 degrees. He selected the second reticle ring and fired at the rightmost Kate. The burst lasted 2.9 seconds, 141 rounds. The Kate's right engine caught fire. The bomber ditched into the ocean trailing smoke. The remaining Kates held formation. Japanese discipline was exceptional. Even under attack, the bombers maintained precise spacing for their torpedo run. O'Hare maneuvered for a second pass, this time from the left side. Deflection angle 38 degrees. He fired 103 rounds in 2.1 seconds. The second Kate's left wing fuel tank exploded. The aircraft disintegrated in mid-air. Third pass, third Kate. The modified sight allowed rapid target switching that standard equipment couldn't match. O'Hare acquired the third target in 0.8 seconds, fired 155 rounds in 3.2 seconds. The Kate's tail section separated from the fuselage. The bomber tumbled into the ocean. 3 Kates destroyed. 7 total kills for the morning. Ammunition remaining, 656 rounds. By 11:30 hours, the Japanese attack had been repulsed. Of 36 Vals in the first wave, 23 were shot down before reaching Yorktown. Of 18 Kates in the second wave, 14 were destroyed. Yorktown took 1 bomb hit, but remained operational. The cost to Japanese carrier aviation was catastrophic. They had lost 37 aircraft and 37 crews, including experienced pilots who could not be replaced. O'Hare landed at 1143 hours. His Wildcat had sustained no damage. The modified sight was intact and properly aligned. Deck crew rearmed his aircraft with 1,600 fresh rounds and refueled. O'Hare ate a sandwich in the cockpit during the 45-minute turnaround. At 14:30, intelligence reported possible Japanese counterattack. Commander Crommelin ordered VF-3 back into the air. At 15:45, O'Hare launched for his second mission of the day. Weather had deteriorated. Cloud deck at 8,000 feet. Visibility 5 miles. Wind from northwest at 15 knots. At 16:20, radar detected small formation approaching from northwest. 6 aircraft, identified as Zeros. Pure fighter sweep, no bombers. VF-3 was vectored to intercept. O'Hare climbed through clouds to 9,500 feet. The Zeros were below at 7,000 feet, unaware of American fighters above them in the overcast. At 16:37, O'Hare dove through the cloud deck with his section. They emerged at 7,400 feet, directly above the Japanese formation. The Zeros were 300 feet below, flying straight and level. 4 seconds of surprise before the Japanese would react. O'Hare selected the rear Zero, the wingman position in the formation. Range 350 yards, rapidly closing. Deflection angle 28 degrees. He fired 127 rounds in 2.6 seconds. The Zero's canopy exploded. The pilot slumped forward. The aircraft nosed down into the ocean. Immediate target switch. The lead Zero was now turning hard, right, aware of attack. Deflection angle increased to 61 degrees as the Zero's turn rate accelerated. This was the modified sight's strength, providing aiming solution for extreme deflections that standard equipment couldn't handle. O'Hare fired 163 rounds in 3.4 seconds. The Zero's left wing route failed. The aircraft spun into the ocean. 2 kills in 6 seconds. The remaining 4 Zeros scattered. O'Hare climbed back into clouds. Ammunition remaining, 366 rounds. 9 total kills for the day. At 16:42 hours, O'Hare orbited at 9,000 feet inside the cloud layer. His fuel gauge showed 40 minutes remaining before mandatory return to Yorktown. Ammunition counter read 366 rounds, enough for 2 more engagements at his current expenditure rate. Below the clouds at 7,000 feet, the 4 remaining Zeros were regrouping. O'Hare could hear their engine noise through his open canopy. The Japanese pilots were calling to each other over radio, voices urgent but disciplined. They knew an American fighter was above them in the clouds. They didn't know where. O'Hare's tactical problem was fuel and ammunition. His section had scattered during the initial attack. He was alone against 4 Zeros. The smart decision was withdrawal. Return to Yorktown, rearm, refuel, live to fight tomorrow. But intelligence reports indicated these Zeros were advance scouts for a larger Japanese strike force. If O'Hare withdrew, the Zeros would report American carrier position to their fleet. More attacks would follow before dark. At 16:44, O'Hare descended through the cloud base to 8,000 feet, where he could observe the Zeros below. They had reformed into two pairs, separated by 200 yards. Standard Japanese combat spread formation. Two aircraft would bait American fighters into attack, while the other two positioned for counterattack. O'Hare recognized the trap. The two Zeros on the right were flying straight and level, presenting themselves as targets. The two Zeros on the left were climbing slowly, positioning for diving attack on any American fighter that engaged the bait. O'Hare climbed back into clouds and repositioned 2,000 yards east of the Japanese formation. At 1647, he descended again to 7,500 feet, approaching the two separated Zeros from their blind spot. Neither pair could see him through the cloud shadows and afternoon sun glare. Range to nearest Zero, 800 yards. O'Hare closed to 400 yards before the Japanese pilot noticed him. By then it was too late for effective reaction. The target Zero was turning left when O'Hare fired. Deflection angle 44 degrees, high-speed crossing shot. The modified sight's fourth reticle ring showed the exact aim point. O'Hare pressed the trigger and held it for 2.8 seconds. 136 rounds converged on the Zero's fuselage. The Japanese aircraft's engine exploded. Burning oil sprayed across the cockpit canopy. The pilot attempted to bail out but couldn't open the canopy against the airstream. The Zero entered a spin and impacted the ocean at 16:48 and 14 seconds. Kill number 10 for the day, 13th total at Midway. The second separated Zero was 280 yards away, turning hard toward O'Hare. The Japanese pilot had seen his wingman die and was now engaging. The Zero's turn rate exceeded the Wildcat's by 15 degrees. In a turning fight, the Japanese aircraft would eventually gain position for a killing shot. O'Hare couldn't outturn him. He could only outshoot him. The deflection angle was 47 degrees and increasing as both aircraft turned. O'Hare selected the third reticle ring and fired his remaining ammunition. The burst lasted 3.9 seconds, 189 rounds. The camera gun showed impacts along the Zero's cockpit and left wing. The Japanese pilot, later identified through post-war records as Lieutenant Toshio Hashimoto, aged 27, died instantly from 50 caliber rounds through the chest. The Zero rolled inverted and fell. Ammunition counter, 41 rounds remaining, 11 kills in 2 days. O'Hare's modified sight had performed flawlessly through every engagement. But as he climbed to 12,000 feet and turned toward Yorktown, he heard multiple engine sounds approaching from the west. He looked left and saw 6 Japanese aircraft emerging from clouds 2,000 yards away. Not fighters, infantry patrol aircraft, twin-engine bombers sent to recover the bodies of downed Zero pilots. O'Hare's fuel was critically low, 28 minutes to Yorktown. The Japanese recovery aircraft were flying directly toward his position. If they saw him, they would report his heading to their fleet. O'Hare descended to 8,000 feet and turned away, hoping the Japanese wouldn't notice a single Wildcat against the darkening eastern sky. The Japanese aircraft continued west toward the area where the Zeros had crashed. O'Hare increased throttle and headed east. At 17:15, O'Hare landed on Yorktown with 7 minutes of fuel remaining. The deck crew counted 41 rounds left in his ammunition cans. He had fired 3,159 rounds across 2 missions and destroyed 11 enemy aircraft. That was 287 rounds per kill, well below the fleet average of 340 rounds per kill with standard sights. The modified sight had saved 583 rounds of ammunition while increasing kill effectiveness. Commander Crommelin was waiting in the ready room when O'Hare climbed down from his cockpit. Crommelin wanted to know O'Hare's total kill count for the battle. O'Hare said 11 confirmed, possibly 12 if the camera gun footage showed the final Zero clearly. Crommelin asked if that included the 4 kills from Coral Sea 3 weeks earlier. O'Hare said no, 14 total kills if Coral Sea was included. Crommelin looked at him for 5 seconds without speaking. Then he said that 14 kills in 2 days was more than most pilots achieved in an entire war. He wanted proof. The verification process began on June 6th. A 3-officer review board convened in Yorktown's intelligence spaces. The board included Crommelin, Lieutenant Harrison, the engineering officer, and Commander Leslie, the ship's air operations officer. Evidence was presented systematically. Camera gun footage from O'Hare's aircraft showed 11 kills with clear visual confirmation. Wreckage recovery teams had retrieved debris from 13 Japanese aircraft in O'Hare's engagement areas. Witness testimony from wingmen confirmed 2 additional kills during the afternoon cloud engagement when camera angles were obscured. Ammunition expenditure records showed O'Hare had loaded 1,600 rounds before each of his 2 missions on June 4th. Total 3,200 rounds available. He landed with 41 rounds remaining. Total fired 3,159 rounds. 14 confirmed kills meant 225 rounds per kill, significantly better than the 287 rounds per kill calculated without the disputed cloud engagement kills. Japanese radio intercepts translated by intelligence officers mentioned heavy losses matching O'Hare's engagement times and locations. One intercepted transmission at 16:49 hours on June 4th reported that an American fighter with unusual accuracy had destroyed an entire zero section in less than 2 minutes. The transmission requested immediate fighter reinforcement to counter the threat. At 14:30 on June 6th, the review board announced its conclusion. 14 kills confirmed. The board's written report noted that O'Hare's performance exceeded all previous naval aviation records for kills in a single battle. The report specifically credited the modified Gunsight as a contributing factor, stating that O'Hare's hit percentage at high deflection angles was 3 times the fleet average. Lieutenant Harrison, who had denied O'Hare permission to use the modified sight 4 months earlier, signed the verification report. Harrison added a personal statement. He wrote that he had been wrong about the sight. It worked. It worked better than any standard equipment currently in fleet service. He recommended immediate approval for fleet-wide distribution and formal adoption by Bureau of Aeronautics. Commander Crommelin forwarded the complete package to Pacific Fleet Headquarters on June 7th. The package included camera gun footage, witness statements, ammunition analysis, Japanese radio intercepts, and the review board's verification report. Crommelin's cover letter recommended O'Hare for the Medal of Honor and requested expedited approval of the modified Gunsight for all fighter squadrons. The letter noted that if every fighter pilot in the Pacific Fleet had O'Hare's sight, American kill rates would increase by an estimated 50%, while reducing ammunition consumption by 30%. On June 10th, Pacific Fleet Headquarters forwarded O'Hare's sight specifications to Bureau of Aeronautics with priority classification. The Bureau had spent 6 weeks studying the sight's design after receiving the initial report from Coral Sea. Now they had combat data from 2 major battles showing consistent performance improvement. Bureau engineers requested 3 sample sites for formal testing. O'Hare built the samples in Yorktown's machine shop using materials scavenged from damaged aircraft. He shipped them to the Naval Air Test Center at Patuxent River, Maryland on June 15th. Testing began on June 18th. Bureau test pilots flew 47 evaluation flights over 2 weeks. They engaged towed sleeve targets at various deflection angles, ranges, and approach speeds. The results confirmed O'Hare's combat data. Average hit rate improved 47% over standard N3 sights. At deflection angles above 40 degrees, improvement reached 53%. High-speed engagements showed 61% improvement. Pilot learning curve averaged 2.3 hours to achieve proficiency, compared to 8.7 hours required for standard sight mastery. On July 2nd, Bureau of Aeronautics issued a formal recommendation. Adopt O'Hare's modified design for fleet-wide production. Estimated cost per unit: 8 tonne on 47, identical to O'Hare's garage-built prototype. The standard N3 sight cost 127 tonne to manufacture. The modified sight was 94% cheaper and demonstrably more effective. The Bureau's recommendation faced an immediate problem. American aircraft factories were operating at maximum capacity, producing fighters, bombers, and training aircraft. Standard Gunsight production lines couldn't be interrupted without reducing aircraft delivery rates. Converting factories to manufacture the modified sight would require 4 months of retooling. The war wouldn't wait 4 months. Japanese forces still controlled most of the Pacific. Every week of delay meant American pilots would face enemy aircraft with inferior sighting equipment. On July 15, 1942, Bureau of Aeronautics issued Technical Bulletin 347 to all Pacific Fleet fighter squadrons. The bulletin contained complete specifications for O'Hare's modified sight, including detailed blueprints, material lists, assembly instructions, and installation procedures. Squadron workshops were authorized to build modified sights using locally available materials. Each carrier air group received $500 in discretionary funds for purchasing aluminum tubing, wire, glass, and mounting hardware. The bulletin designated the device as Modified Reflector Sight, Mark II, Field Expedient. It was the first time in Navy history that a garage-built modification had received official designation and fleet-wide authorization. Between August 1942 and January 1943, squadron workshops across the Pacific built 347 modified sights. Machinists' mates and aviation mechanics who normally repaired damaged aircraft now spent evenings constructing precision optical devices using hand tools and improvised jigs. The average construction time per unit was 8 hours. Total materials cost per unit remained 8 tonne on 47, exactly matching O'Hare's prototype. Combined program cost was $2,141 for materials plus labour hours that would have otherwise been spent on maintenance and repair work. Installation was simple. The modified sight mounted to the existing N3 bracket without requiring aircraft modification. Pilots could install or remove the device in 8 minutes using standard tools. This allowed rapid distribution. A carrier air group could equip its entire fighter squadron in a single afternoon. By October 1942, every carrier in the Pacific Fleet had at least 12 modified sights installed in frontline fighters. Combat results validated the investment. Between August 1942 and January 1943, Naval Intelligence compiled kill statistics from camera gun footage and pilot debriefing reports. Pilots equipped with modified sights achieved 823 confirmed kills across 4,137 combat engagements. That was 19.9% kill rate. Pilots using standard sights achieved 1,247 kills across 9,638 engagements, 12.9% kill rate. The modified sight increased kill probability by 54% while reducing ammunition consumption from 356 rounds per kill to 247 rounds per kill. The Navy's top aces credited the modified sight with significant advantage. Commander David McCampbell, who would finish the war with 34 kills to become the Navy's highest-scoring ace, installed a modified sight on his Hellcat fighter in March 1943. McCampbell's combat reports consistently mentioned the sight's effectiveness at high deflection angles. He wrote that the additional reticle rings eliminated guesswork from deflection shooting and allowed him to take shots that would have been impossible with standard equipment. Commander Cecil Harris achieved 24 kills. Commander Eugene Valencia achieved 23 kills, and both attributed multiple victories to the modified sight's precision at difficult angles. By March 1943, Bureau of Aeronautics had completed factory retooling and began production of O'Hare's design as standard equipment. The production model was identical to the field expedient version, except for chromium-plated steel mounting brackets that replaced the spring-loaded clips O'Hare had used. Production units cost $12.30 to manufacture, still 90% cheaper than the standard N3 sight they replaced. Between March 1943 and August 1945, factories produced 6,147 modified sights that were installed in Wildcat, Hellcat, and Corsair fighters throughout the Pacific Fleet. O'Hare never saw the mass production. On November 26, 1943, he was leading a night fighter mission near Tarawa Atoll when his Wildcat was hit by gunfire. The exact circumstances remain disputed. Some evidence suggests Japanese rear gunner fire from a torpedo bomber O'Hare was pursuing. Other evidence suggests friendly fire from an American gunner who mistook O'Hare's aircraft for an enemy plane in darkness. At 1947 hours, O'Hare's Wildcat crashed into the Pacific Ocean. Search and rescue aircraft found debris but no survivors. Edward O'Hare was 29 years old. His final combat tally was 17 confirmed kills, including the 14 achieved at Coral Sea and Midway with his garage-built Gunsight. The modified sight that O'Hare had installed in his final aircraft was recovered from the wreckage by Navy salvage divers in December 1943. The device showed impact damage, but remained structurally intact. The aluminum tubing was bent, the glass was cracked, but the reticle rings maintained their precise spacing. The sight was preserved and eventually donated to the National Naval Aviation Museum in Pensacola, Florida, where it remains on display. The placard reads, "The garage-built gunsight that changed aerial combat, designed and built by Lieutenant Commander Edward O'Hare for $8.47 in materials, credited with enabling 14 confirmed kills at the Battle of Midway without a single miss." On April 26, 1944, President Roosevelt presented the Medal of Honor to O'Hare's widow. The citation recognized O'Hare's exceptional combat skill and technical innovation. The citation specifically mentioned that O'Hare had designed and built specialized equipment that significantly enhanced American tactical capabilities in aerial combat. This was unusual language for a Medal of Honor citation, which typically focused on acts of valor rather than technical achievement. But O'Hare's contribution was unique. He had recognized a problem, engineered a solution, proven its effectiveness in combat, and then shared that solution with the entire fleet. In 1949, Chicago's Orchard Depot Airport was renamed O'Hare International Airport in his honor. The airport would grow to become one of the world's busiest, serving 83 million passengers annually by the 21st century. Millions of travelers pass through O'Hare Airport each year, most unaware that the facility's namesake was a fighter pilot who built a gunsight in his garage and used it to shoot down 14 Japanese aircraft without missing once. The technical legacy extended beyond O'Hare's lifetime. Korean War F-9F Panther jets used computing gunsights that incorporated O'Hare's principle of multiple reference reticles for different deflection angles. Vietnam War F-4 Phantom fighters employed lead computing gunsights with electronic systems that performed the same calculations O'Hare had done mechanically with aluminum rings and glass. Modern fighter aircraft use head-up displays and helmet-mounted sights that project aiming solutions directly into the pilot's field of view, but the underlying principle remains identical to what O'Hare developed in his Coronado garage in 1942. Calculate the deflection angle, determine the required lead, and show the pilot exactly where to aim. The story of O'Hare's modified gunsight represents an unusual intersection of individual innovation and institutional adoption. The Navy's initial response was skepticism and regulatory resistance. Lieutenant Harrison had laughed at the garage project. The Bureau of Aeronautics had insisted on months of approval process. But when combat results proved the device's effectiveness, the institution adapted. The Navy distributed blueprints fleet-wide, authorized field construction, and eventually integrated the design into standard production. This was the military bureaucracy functioning as it should, resistant to unproven modification but willing to adopt demonstrated improvement regardless of source. O'Hare's fellow pilots in VF-3 had called his modified sight jewelry and mail-order equipment. They had mocked the idea that a garage project could outperform Navy-approved equipment developed by professional engineers. The mockery ended on May 7, 1942, when O'Hare shot down 4 Japanese aircraft in 5 minutes. It ended completely on June 4, 1942, when he destroyed 11 more in a single day. The pilots who had laughed in April were requesting their own modified sights by June. The engineering officer, who had denied permission in March, was recommending fleet-wide adoption by July. O'Hare had proven that innovation could come from operational experience rather than laboratory development, that pilots who understood combat requirements could design solutions as effective as those created by engineers who had never faced enemy fire. The modified Gunsight achieved what every weapon system aspires to achieve. It gave American pilots a decisive advantage that couldn't be countered by Japanese tactics or training. The Zero remained faster and more maneuverable than the Wildcat throughout the war. But American pilots with modified sights could shoot with 3 times the accuracy of their opponents. That accuracy advantage, combined with superior American industrial production, ultimately determined the air war's outcome. O'Hare's 8-47 Garage project had influenced the course of the Pacific campaign in ways that billion-dollar programs could not match. The man they had mocked for his homemade equipment had built the most effective aerial gunsight of World War II using hardware store materials and high school mathematics. His innovation saved American lives, destroyed enemy aircraft, and changed how fighter pilots would aim their weapons for generations to come.